Okay. Here's this chat, and here's. Okay, okay, okay. And hello, hello, hello. Hello? Okay, I think you can hear me. Alright, let's switch scene. Not sure if I'm live on all the right places. So I'm gonna check that first. Looks like I am live on Twitch. Maybe? Okay. There's just a huge delay. Okay. Okay, I think I'm live. All right. Hi, hello. My name is Daniel Duan, and today I wanna. Hey, Anton. Today I'm going to try to write some Swift, read some Swift, play with some Swift, maybe. Yeah. So the first thing I want to do today is to check out a new framework shipped with I guess Xcode 14, which is called System. So let's see if what we can find here. All right, System performs low-level file operations using type-safe APIs. Very nice. So we have some documentation. Well, that's documentation is a strong word. I guess we have some sections for doc strings, and it looks like we have our mapping from POSIX errors or so-called C errors to what are these? Okay, it's just some static vars on a struct. Fair enough, fair enough. I mean, I've briefly checked this out when it was discovered during DubDub, but I don't think Apple announced it officially. I mean, like releasing it publicly, probably. So, anyways, these looks like the majority of the APIs, right? So you can pwrite, pread, read write, and open and seek and close, right? Pretty simple. And we have types for file descriptor. So when you open the file, you get a descriptor. We have we have a struct called file path. Fair enough, self-explanatory. File permissions is all these basically your typical POSIX permissions, right? Cool. And that's it. Then you got your error number. So super simple, super lightweight, right? So I guess the most interesting typing here is file path. I mean, I don't want to go through how POSIX file works or C file works. I assume, if you don't know, you can look it up yourself. But path is the most interesting one because I want to look at what kind of property it has. So path is a null terminated sequence of bytes. Okay, so they're in bytes, have the null character towards the end, and it has a length, which is probably the number of bytes. Description, interesting thing actually. Yep, and you can take a C string, and we'll just copy it, and then you can convert it. You can get the C string back temporarily if you want. Cool. Nice. File path. Okay. Yeah. So why am I checking these out? Right. Let's look at this example real quick though. So here's the string and here's a file path. Here's a file descriptor for this path. And here's your permission, well, not permission, mode. Let's call it mode, right? Actually, that's probably worth checking out. And then there's options, file descriptor. So when you open, you give it access mode, file descriptor. So there's more things here. Open options and permissions. Okay. And access mode is your typical read, write, RW and W. Okay. Yeah. So this is pretty neat, and I think someone from the Swift team said this eventually become open source. That would be really nice because obviously this could work on Mac OS and Linux, and to some degree Windows. Although the error numbers won't work, won't at least match 101. So maybe some of these will be marked unavailable, and maybe some new things will be added specific for Windows. But overall, I think this is a pretty cool API. So let's play with it. I'm going to make a new playground if I can. macOS playground. Where is it? Oh, new playground. I know the shortcut for that. Okay. It's a whole bunch of keys. Let's make it macOS. System play. Okay. So let's play with it. I think I can close this. All right. I don't need any of this. So import system. And for now, I'm going to make it auto eval. All right. Okay, so let's just use that example. Let log equals try, I don't know, file descriptor. Actually, I want to play with file path. So let path equals file path. So you can give it a string. Let's do that. Very ergonomic. Log. I think, okay. It's only available at macOS 11 or newer, so let's do that. If available, macOS 11. And then no big deal. That is interesting, but oh wait, what am I doing? If it's available on macOS 11, I'm using macOS. 15, the macOS 10.15 obviously won't work. Okay, fine. I'll just play with it as if it works, okay? I just want to get a feel of how it works. So there's very little thing you can do because it's literally a byte buffer. So you get to get the length, and then you get a with sysstring, and then you get the unsafe pointer. Unsafe pointer is not an unsafe mutable pointer, so which itself is pretty interesting already. Okay. Yeah, I can dig this. Yeah, so that's file path. So the reason I'm checking this out, the real reason, is I'm a owner of a very similar library, a maintainer, I should say. It's called Pathos. So if you go to d1/pathos on GitHub, it's a file system library. I'll just point out some interesting facts about system and Pathos. First of all, let's take a look at file permissions. So system has the file permission type, okay? It represents your Unix file permissions, right? Owner read, owner write, owner read write, owner read execute, blah blah blah, group read, group write, and then other read, other write. Now let's look at this file here. So in Pathos, there's a type called file permission. Okay? And what's in file permission? Owner all. Owner read, owner write, group all. I mean, obviously, this is kind of an obvious idea. Except the interesting thing I want to point out is that the naming convention is actually very, very similar. Yeah, and these are option sets. I assume this is also an option set. No, it's a struct, which is... Wait. No way, it's not an option set. Yeah, it is an option set because you can use this syntax there. So that's basically essentially the same thing. And then there's special permissions for set user ID on like execution, set group ID on execution. And I don't know what save text is, but I assume it's just another thing here. Oh, it's right here. Anyways, yeah. All right, so extremely similar, right? It's an option set. It represents the permission. Okay, interesting. Now, in Pathos, the focus is path manipulation, which means so you get your path, right? Let's say we can create a temporary directory. This is part of this library. And then you can do glob, which is part of this library. And then from glob, you get some paths back. And then you can say, oh, what's the base name of the path? You can join the paths to another thing. And you can manipulate. Basically, you can think of all the things you can do with a file manager on an OS, right? Yeah, you can move the path, blah, blah, blah. So the focus is manipulating, creating, and the file system, the virtual file system in all OSs, right? The only abstraction differences is that since the focus is on path, Pathos doesn't really have a concept of a file descriptor. That's number one. And number two is, I guess it's in retrospect, it's pretty obvious, but path uses a string to represent the path, Swift string specifically. And I said in retrospect it's pretty obvious because all this library does is, well, not all, but a lot of what this library does is calling into the POSIX APIs, either from Linux or Mac OS, and sometimes Windows. There's a branch I'm working on. But when POSIX API gave you a path, it's a C string, aka it's a byte array. So naturally the most efficient way to represent a path. If you're thinking someone may require a lot of path manipulation, is to directly take that byte array and don't do anything with it, and assume user may not ever do anything with the byte array, right? So that's and if user needs to do anything with a byte array, let's say they want the base name or the the URL, the directory name, or things like that, they can still get it in the form of bytes or strings. So that's an interesting trade-off, and it's an interesting design things to think about. So yeah. Anyways, so I'm thinking this is where I want to take the direction I want to take this library to. Either I build on top of system, assuming it's going to be open source in the future, or I emulate what system does. Oh, this is interesting. File descriptor has a thing called seek origin, and it has all this interesting little tidbits. Anyways, yeah, either direction is fine. I just want to have a very handy library to manipulate the file system, right? So for now, though, the file path type from system gives you the length and string. So let's try to write one ourselves. Okay, let's try to run our own file path. Not in this one. Probably in that storyboard I made earlier. Is it already open or something? Okay. All right. So what is the file path? Right? It obviously could be a buffer pointer. Unsafe buffer pointer. And then let's call it cchar here. And I don't know why I'm trying to initialize this. Let's just call it like this, right? And you'll have this will be private. And then we'll have the length property, which if I were to rename it, I would call it byte length. Yeah, I mean, if you have read documentation, people will learn what length means. So maybe this is fine. And this is simply buffer.count. Maybe even buffer.count +1, if you're thinking it's a null terminate buffer. Let's see if they actually explain it. Yeah, so it's excluding the null termination. That's fine. All right. Yeah, and then you have what with C string, right? Func with C string. What's the signature here? You have a result. Okay. Unsafe pointer to cchar. I don't like the choice of just int 8 here. Maybe they'll change it. Cchar, and then it's a closure, right? So this will be a throwing closure. This is result. Result is just a generic name, a generic parameter. Okay. Return the result. And yeah, we'll have to give this a name, I guess. Let's call it closure. And then let's implement this. So what do we give this closure? This closure will get a unsafe pointer. So that would be. This is also very interesting. Why would it be an unsafe pointer as opposed to a buffer pointer? If I were to design this, I would make it an unsafe buffer pointer, right? And we simply call closure with buffer. Wait, there must be a array throws. Okay, yes. Okay, so that's it. Pretty simple, pretty straightforward. This might as well be the implementation for this, and it's even better. Okay, so let's see how practical it is, right? Oh yeah, let's make it init as well, I guess. Yeah, I guess they're going with the C string pattern, which is why they're using unsafe pointer as opposed to unsafe buffer pointer. But we'll see if there's a practical reason to do that. C string is gonna be unsafe pointer of C char, and yeah. So we need to copy. Let's import some C APIs here. Unless there's a copy. No. All right. If this is C, you can write a while loop and say, oh, pointer not equals a pointer, while pointer something something. Yeah. The clever little while loop. But here we can use I don't know. Yeah, I don't know. How do you copy a C string? You can do stir dupe, right? Stir dupe, C string. Yeah. I don't know. Buffer equals start and count, right? What does stir do? Does stir do give us the length? Copy the string. Yeah, there's the end version. It returns memory. Yeah. Okay. Well, there must be a better way, right? How do you copy a C string and get its length? Do I need to call two APIs? Like start equals stir to C string, and then count equals stir len C string. There must be a better way, right? Buffer equals start init, start buffer, start count. Seems A little slow. A little slow. I don't know. Let's Google it. Let's learn some C. Copy C string and get length. How we go strings in C? Let's go to the next one. Maybe stir dupe with length. Get length. Okay. Yeah. So there's also string copy. I guess I can do string copy as well. All right. Okay. So now we have our own version of path. Okay. Uh, let me think about this. Certain function allocates efficient memory for copy of string S. Does the copy and return a pointing to it? The pointer may subsequently use an argument to the function free. If insufficient memory is available, no, okay. So there's also, I guess, error handling we could do here, right? So we can do guard let else. We'll get an error, which is the error no, right? Error no is set to no. Okay. So now we need to return our system error. Let's just make a dumb struct for that. I don't know, IO error or system error or just error no. And then raw value. I think error no is like an int 32 or something. Here we can just throw error no, raw value error no. Okay. Yeah, so that handles that. Blah blah blah. The start and then okay. So sufficient memory, I assume, is gonna include the null termination. Okay. So basically, we're using a CAPI to do this. Yeah. Okay, so let's find a C API and try to use it with our path and see how that goes, right? I don't know. There's least dir, I think, or least dir. No, dir fd dir name. Get CWD even. Right, get CWD, for example, gives us the unsafe mutable pointer. Get man3 get CWD, get working directory path name. It copies the absolute path name of the current directory into the memory referenced by buff and returns a pointer to buff. The size is the size in bytes of the return referred by of the array referenced by buff. If buff is null, space is allocated necessary to store the path name and size is ignored. Space may later be freed. Yes, that's probably what we want, right? So an example of getting the current directory with our new type would be we use our C-string initializer, and then we just call get CWD. It's as simple as that, right? Get CWD, this will be nil, this will be 0. Yeah, of course we'll run try. Okay. So to indicate, to see whether this succeeds or not, let's do P like this, and then P dot with C string. So this is a buffer pointer, so we can do string C string $0 dot start $0 dot point. Wait, with C string. I thought you can do like dot start or something. No? How do you use a buffer pointer? Base address? Yeah, base address. Okay. And is this our path? Yeah, okay. So that's our current working directory, I guess. Okay, so this is how you use the system path with like C API, such as get current working directory. So let's see. String C string unsafe pointer C char unsafe pointer blah blah blah. So this just assumes UTF-8 decoding, which I'm not sure I like. Also, I'm starting to think using an unsafe buffer pointer, is it really better than using, say, an array? Right? I mean, an array of C chars and the closure. I mean, I might as well give you full access to read access to the buffer, right? At this point, and then here we can simply say, yeah. Buffer equals count initializing with wait, I don't know. I never used this. I've seen people talking about it, but I never used this. Let's try this. Array. Can I find this here? There we go. Create a memory specific capacity, then call the given closure with the buffer covering the array's uninitialized array. Yeah. This is good. Right. Call this. Then we do this, and this is a closure. We got our buffer here. We got our count here. And in here, we can say buffer. It's unsafe mutable buffer pointer. Okay, buffer init start and count maybe. Right, now we don't need to do this anymore. P would just be wait, something is wrong. Oh wait, this pointer is already initialized, right? So this buffer, we can just we allocated the buffer. So we can do stir copy destination buffer source C string maybe. Maybe this is a stir n copy, and then we can do the count thingy. Even count +1. Actually, I don't know. Finds length of the string, blah blah blah. Computes the length of the string s. N as attempts to compute s, but never scans beyond the first max length of n. Returns the number of character precedes. No. Okay, yeah. That makes sense. So we copy one extra here. So this should be okay, right? I don't need to do this anymore. This doesn't look right though. Initialize count. What is count? Count is 1. Why isn't this working? Stir copy and stir copy string to dest, including includes the termination character. So maybe I don't care. I mean, start and copy is like, the safer route. But I feel like I'm missing something. I'm missing how this thing works. So buffer is of a type of unsafe mutable buffer pointer, I think. So I'm calling string copy, but why isn't it working? C string. Pointee. It's ASCII character 47. Is this not how I use it? Initialize the closure sets the initialize count parameter to the number of elements that are initialized by the closure. Initialized by the wait, what? Initializer. Inside the closure, set the count parameter, the number of elements. Oh, I have to set the count as well. So count equals, I don't know, len. Does this help? Len. Response 1. Ah, okay. There we go. I need to set the count. Makes sense. Makes sense. See, we're learning. We're learning. This is a I think this is relatively new, right? Yeah, it's 11 x11 plus x code 11 plus. So yeah. This is very cool. All right. Now what? Now what? Now we have a path. It's a array buffer. Now we can do interesting things to it, right? Like we can, yeah, the interesting thing is we never need it to be, sorry, we never needed to become a string. And to take a step further, we can even do like string, right? We can actually take a string. And in this case, buffer is just string dot UTF-8 C string continuous array of string. I don't know. Can I do this? Yeah, so it just works. Right. Okay. Yeah, so I'm thinking I should take this definition and replace what I have in Pathos with it, right? Code, Pathos. But it requires quite a bit of big surgery, to be honest. First of all, let's change the default branch name. It's going to be super easy. Not super easy, because this is a library, but I'll just use main for now. So if I look at path representable to begin with, path representable, it's like you must have a path string. Which is like in this new world, it won't be, right? So I need I think protocol is very flexible thing. So let's think about this. File path in system has length and with C string. So let's come up with something that can make. Okay. How about this? I need to come up with a better name than buffer. Buffer is just a placeholder. Let's call this path bytes, path buffer, or path bytes. If it's not for a protocol conformance, I would just call it bytes. Okay, so this is a simple replacement. Okay. Now let's call the protocol path representable. It will have path bytes, which actually, let me think. What is better? Is so file path in system framework is read only, right? Because you get with C string and then it's not a mutable pointer. It's a value. It's almost like a value type. So maybe yeah, I don't know. I'm conflicted. I'm not sure. I'm not sure whether this is a good idea. Like if I make this an array, okay, and then we see you must have a getter for this. I mean, array doesn't have really a performance concern given we can do things like this. And the performance concern really comes when you try to decode it into a Swift string, let's say. But can I make this conform to this? Yes, I can. But the problem is this enough? Is this enough? Evidently, yes, because I guess this is read-only as well. Okay, so we can easily make the system path conform to this protocol, which also means if we just build all our functionality on top of this protocol, then we can optionally import this framework, and then the framework types automatically get our functionality through our framework. So that's good. That's a good pattern. That's some good stuff. Okay, so this could be the foundation for the next iteration for pathos, right? Well, let's just illustrate what I mean. So if available Mac OS 11, um, then we will import. Can I import inside here? Import system? No. Let's just do it top level, no problem. I mean, this we can even wrap it into like if can import system, and if, right, something like this. And I think I still need this here because, just because, file path. Okay, maybe this compiler condition is good enough, but maybe not. File path. Yeah, maybe not. It's okay. If available Mac OS 11. So if this is true, well, extension file path to our path representable, and path representable has one requirement. Oh, so maybe this is like an add available. Makes sense. We happy? Okay. Cool. Now we can finally add our thingy. And this is just a getter, so it's easy because we literally just do this. Oh. We do with C string, and then that's our pointer, right? I feel like we're just duplicating this. So maybe I can just do pass C string. I'll try here, sure. And then C string dot this. Right. So we can do try here. Right. And then we have to do this maybe and something like this. I need to think about this a little bit more. Okay, so I think this means we're good. This is just some silly examples, silly errors. Yeah, so we take the system.filePath type, and now it conforms to our path representable. Okay, so from this point on, we can implement, we can conform, obviously, also conform path to path representable. This is free. Okay, and then we can start implementing a bunch of things on this protocol. Then both our path type and system.filePath will get the functionality. Things such as, is this path the absolute path? What's the drive? On Windows, there's a drive concept. What's the drive for this path? And what's the file name? What's the directory name? And what are the each levels of directory name, given one by one? Things like that. Yeah, I don't know. I guess this is no longer necessary. Taking a C chart definitely is pretty clever. Yeah. Another path I could go is just totally ignore the system one, just implement my own thing. That's definitely something to think about. And we can make this like a read-only, right? We can make this like a value. It's just a wrapper for an array of bytes, right? Like we can make this more approachable. And just get rid of this. Yeah, okay. Yeah, it's called path bytes. Path bytes. If it's a concrete type path, I'd rather call it bytes or buffer or something. This is fine. Yeah, this is fine. Okay. Dare I start making changes in my actual project like this? Let's make a branch. Bytes oriented, something like that. This project has a lot of tests, if I recall correctly. So that's good and bad. Good meaning we would know if something's broken. Bad meaning we potentially have to update a lot of tests. Yeah, this library is used in a lot of places in production, so like it's pretty good. I remember catching a lot of bugs and fixing them. So let's just use Xcode. Maybe not this version of Xcode. Okay. So path representable. Let's start here. No, I don't know why I want to do it this way, because everything will break, right? Everything, literally. Everything. On top of that, there's a work in progress for Windows that changes a bunch of things, like a lot. Yeah, like I implemented slip drive here. Yeah, using a bunch of stuff, path notification for Windows with more tests and all that. Man, it's gonna be an interesting project. Interesting project. Hmm. 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 Okay, how long have we been streaming today? I just don't feel very inspired today. I knew going into this is not gonna be a super simple thing. It requires some inspiration and motivation. But I do think this is a good exploration of this domain, and I do think, um, you know what? Let me just start. Let me just conclude by starting a new project. How about that? Let's call it Pathos 2. But it's not going to be Pathos 2, it's going to be Pathos Next, right? And let's do Swift package init. And you know what? I have a better idea. Pathos 2, Pathos, Pathos. And then here we do Swift package init. Wait, let's take a look at here. 5.2, everything is okay. We don't need dependencies. Dependencies is not for system framework. Then we have test target and a target. And our product is a library. Beautiful. Okay, here we just add two files, right? Simple as that. First one is not this. Let's delete it. And then first file is path.swift. And here we just take this. Is there no way to copy base address copy? I don't know. Unsafe pointer Swift unsafe buffer pointer copy. How are they actually doing the copy? That's what I'm curious about. What is this example? So there's input, you get a raw buffer pointer, you get the data, base address, bind memory too. Okay. Append. No, this is not what I want. It's not what I want. Copying a value of type buffer pointer does not copy the instance stored in the underlying memory, initializing another collection with other copies. Mm-hmm. Mm-hmm. So when it comes to just a list of bytes, basically the problem I'm trying to solve is like, can I do this without using stir copy? I do feel like it's not impossible, right? We have two pointers. We need to copy its content, one's content to the other. Doesn't seem like a daunting. thing. So buffer dot assign every element's buffer value to a copy of the given value. Yeah, no, thanks. Initialize from. Initialize from a sequence. So sequence would be unsafe buffer pointer start with C string, and the count would be length, right? But then I'm still relying on Sterling. So this is still not good enough. Not good enough. Okay. So I could do something silly like, I is 0, and then while right. What's the This feels so inelegant. Well, I just want to move the pointer forward until it's a 0 character. Okay, that's easy. I guess I need let's just use a dumb counter for now, and then we can do right buffer buffer I equals C string while do while statement is not allowed. Gosh darn it. You see, I don't really know how to write Swift, right? Obviously, I'll advance this as well. And towards the end, we'll do count equals I or something like that. Ah, wait, then I wouldn't even have this. Ah, yikes, 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 yikes. Yeah, without C API, this is really awkward. How do people do this in C? You just allocate a buffer, so you already know kind of what to anticipate. And then like you know that your allocation is going to be enough, or you can update it later. Its capacity, and then you just do no. You just use like magical things like stir dupe, which will okay. So it would be something like um length. Yeah, you basically implement stir length first, right? And it's gonna be linear anyways. So you do like length equals 0, and then you do while uh, I mean this is pseudocode. I'm not gonna ship it anyway. So it's while string dot advanced by len is not 0, len plus 1, right? Now you have the length. Oh, point T, I mean. So you walk through this byte array until +1 also takes care of including the null terminator. Okay, now you have the length. Now you can say buffer unsafe buffer pointer. Start being the C string, the count is the length, right? This will give you the unsafe buffer pointer. And then can you just say buffer equals and count equals count? Oh, wait, count equals length. Okay. Type unsafe usable buffer pointer. Right. Initialize from unsafe buffer pointer C string length start is C string, the count is length, the count is length. Length again includes the null terminator. In my case, I probably don't want to include the null terminator. Obviously, don't need to do this. I may even want to take the null terminator out. So, like, length should. I should keep the get CWD example here. So let's do path C string get CWD. I have import Darwin up there. So here let's give it a nil and a 0. Okay, so that gives me path. And what's in its bytes? And what's our length here? It's 1. Right. The length will be correct. Yes. So here we managed to not use any C API. I don't know if that's better or not. Because we're walking through the string twice. Once to find the length, its length, and the second time to copy over it. And we also do a allocation. I don't know what's the fastest way. Fastest way to copy string in C? I don't know. Fastest way to copy C strings. Proper way to copy C strings. Stir dupe. Yeah. Stir copy, but needs to allocate space first, which isn't hard to do, but can lead to overflow errors. Yeah, you have a string here, and then you malloc +1. Stirlen, yeah. Cannot use stir dupe, programmatically use stir and copy instead of copy. Yep. No, some of these are not great. I'm not surprised, but efficient string copy. If you're just recommending stir dupe, then I'm not really interested. What's stir cat? Oh, concatenate. Yeah, C is weird. It's like sometimes it's under the assumption that you don't care about the exact length of the string. You just have assumption of a maximum, and then OpenBSD stir copy. POSIX mem copy. Mem copy. Yeah, that also works. I don't know if that's faster than stir dupe. Choosing a solution. Yeah, I'm solving some problem that's. Oh. Let's see. Memchar. Also, I'm not sure if I'm just over engineering this, right? Because eventually I'll have to import POSIX API. Yes, I can do all this stuff without importing, but that's it. That's where I stop, right? This doesn't count. This is as far as I get without the POSIX API. Yeah, interesting. Okay, let me just finish the stream here. Before I go any further, let's make a move from temp pathos to pathos 2. Pathos 2. Sources. Pathos path. Okay, what's in the path? So let's just put this in here and think about it a little bit. It's a funny problem. Yeah, we're basically paying for C's API convention. All right, fine. buffer dot um yeah, this is not terribly bad. Buffer dot initialize. Initialize buffer memory with given elements when called. When calling the no, let's just do stir. Terribly thinking, overthinking, terribly overthinking. Let's try this again. Okay, we have an unsafe mutable buffer pointer. Unsafe mutable buffer pointer. Slow level range uniqueness checks and release spell. Semantics buffer pointer is low. Does not own the memory that it references. Copying a value of type of pointer is just a pointer. Sure, initializing another collection with a pointer instance copies out of the reference memory. Blah blah blah. Okay, so what can I do with this, right? Initialize mutating base address, a pointer to the first element. Okay, so what if I do stir dupe C string stir len piece. Oh, this has to happen early. Okay. Maybe? It's get only. It's get only. Get only. Okay. Yeah, that's why I'm confused, because I already have a buffer, a pointer. Wait, is it an in-out buffer? It's in-out, right? Oh, so I can change it. Okay. So it's actually very simple. Stir dupe C string length. Is this the best way to do it? Array. Init. Repeating. Where is this documented again? Oh, it's contiguous array. That's why I couldn't find it in array. Okay. I mean, that's something to consider. Maybe this could be a contiguous array of char. So is this the most efficient way to do it? Well, yeah, I'm still doing this silly stuff. Um, import Darwin. Here's a Sterling C string. Now I know the length of it. I can use it here, and then get the buffer, and then play with the buffer. But inside, when I play with it, I say buffer.initialize from unsafe mutable pointer buffer. I just need to make sure this initializer doesn't make a copy. Then I'm good, right? Which I don't think it should. Doop, 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 doop. Start count. Create a new buffer pointer over the fixed number of contiguous indicators beginning of the given. Right. Okay. Okay. Okay, so this is our path implementation. Result initialized from is never used. Initialize from. Wait. Initialize from. Oh, that's in, I don't know. On safe mutable buffer pointer. Okay, I have a feeling that's not really what I want. Responsive mutable pointer. Mutating. Actually, I wanted to do stir dupe here. Oh, stir dupe gives me the right point. Yeah. The real question is I feel like this wasn't correct. Or maybe it was. Maybe this is it. It's that simple all along. Okay. Yeah, it definitely was like overthinking a bunch of stuff. Yeah, but with CAPI, everything becomes super simple. So you can just Swift build. This shouldn't be any problem. You know what? I'm gonna hold off the path representable thing until later. Okay, so that's it. We've made this little path, this 17 lines, including empty empty lines, new lines, and prints and imports. That's all we got for an hour and 40 minutes. And there you have it, ladies and gentlemen. Thanks for watching this stream. Please, if you're watching it not on Twitch, consider following me on Twitch. And if you're watching this later on YouTube, give me a like or something. Yep. And that's it. Thanks for watching.